we need to remember what PV and FE represents. Okay, so do you need equations? No. You have the calculator. Okay, you're going to use the calculator as much as you can. The only time I use this is if I have a theory question. Okay. If I'm working out PV, am I going backwards or forwards? Correct. Okay, so this is moving in that direction. If it's future value, it's moving in that direction. Correct. Right, so what's the difference between a nominal and effective rate? Do you remember?
Nominal is the quoted rate.
So do I use that in the calculation? No. What do I use?
Use the effective.
Correct. Okay, the effective is what you actually get. Right, so effective rates take reinvestment into account. Okay. What is the equivalent rates formula? There's it. Okay, sometimes you are going to need it to work out an I that's specific to the question. Okay, so can I use a monthly rate with quarterly payments? No. Would I use this? Yes. Okay, I would have to use this formula to convert the monthly rate into a quarterly rate, because now I'll have a quarterly rate with quarterly payments. Okay, so is there a shortcut when working out I1? Do you have to use the formula for I1? No, you can use the financial calculator.
I1 being the yearly payment.
Being the EFF. Remember that?
Yes.
Okay, so how would I work out this amount? Okay, so we know the answer is that, right? But now let's do it on the calculator. Do you remember the steps? Kind of. No. Okay, so remember we said when you go second function clear all. Okay, second function see all. What do you read on your screen? Is there a 1, a 2, a 1?
So
Okay.
I want to change it to a 4.
So you only ever change it for this calculation.
So I say 4, second function, PY.
Yes. And then you put in the rate. 8 is I.
Okay, so 8.
I over Y.
There we go.
And then you press second function EFF. What did you get?
So 8. So 8.243.
Is that the same answer?
Yeah.
Correct. Okay, so you don't need to do it this way for I1. Only for I1. Okay. Alright, is that alright? Great. Okay, then we also, just a recap from last week, continuous compounding. Define it for me. What is continuous compounding? How is that different to normal compounding?
It's constantly.
Exactly. So how big or small are those intervals? Infinite amounts of intervals. Good. Okay, so this is looking at the limit in terms of compounding. If I could compound yearly to monthly to daily to per second, and I could do that continuously, okay, what would I have in terms of a limit? Okay, a limit towards a specific amount. Okay, limit to infinity basically. Okay. Alright, so today we're looking at annuities. Okay, nice and simple. The focus here is on this. The PMT. Okay, that's what you're looking at. Okay, you're looking at the payment. Right, so if you look at your calculator, you'll see PMT as one of the variables on that particular calculator. Right, for us to use that variable, we need to determine what is an annuity. Okay, so when do I use that button? Okay, I use the button when I have a sequence of equal payments. Right, so is this an annuity? Correct. Is this an annuity? How do you know that?
It's uneven spacing.
Okay, that's a good observation. Right, so you've correctly identified that as being uneven. Okay, we don't know if
That doesn't have anything.
the amounts are, yes. Okay, so if the amounts were the same, okay, would that be an annuity?
No.
It would be, but it would be a deferred annuity. Deferred means it's starting later. Okay, so the question is,
Equal payments at equal intervals of time. So if you put the 5 at the first interval, and then 5 at the second point, and then 5, so on, would it still be an annuity even though it's not equal points of time?
no, it must be equal points. So here we have equal points.
Yes.
Alright, so here we could possibly have an annuity.
What I'm saying is,
Yes? If I put a 5 here,
if you put a 5 there,
then it wouldn't
then it's
be.
not an-
Correct. Yes, so if I put a 5 here, then it wouldn't be, but this would be. Okay, but yeah, there's consideration for annuity or not. The answer is maybe. Would this be an annuity? Okay, it wouldn't because it's just a PVFE calculation. Right, annuities are only, let's say, present if you have multiple payments. Yeah, is the last one an annuity? Correct. Okay, the 2,000 is different to the 1,000. Okay, only because that 2,000 is there, it makes that a cash flow rather than an annuity. Okay, make sense?
Yeah.
Perfect, good. Okay, then a little bit of theory. The textbook talks about two types of annuities. Ordinary and annuities due. Okay, there's the first and there's the second. Right, it's still an annuity, so we still have regular equal payments. The big consideration is when do the payments start? Okay, so if it's an ordinary annuity, if this is time 0, okay, time 1 would be 1 period after. Okay, where does the first payment appear? At the end of each period. So end of each period, so the payment would start there. Okay, so the present value would be here. Okay, present value at time 0, then payment, 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 and so on. Okay, if it's an annuity due, then you're looking for that particular scenario. Okay, because on all calculators except for the HP, the default setting is end mode. Okay, if you change the mode on your calculator, it won't change it back when you second function clear all. Right, so just have a look at your calculator. Do you see where the begin/end button is? It's a second function. BEG/END.
Yeah.
Great. Okay, so if you press second function that button, then you'll see BEG on the screen. Okay, now if you press second function clear all, it'll still be there. Okay, what's the default setting? End. Okay, so you need to remember, if you do change it on your HP, make sure you always change it back. Okay, because we only ever change it to begin mode if the question specifically talks about start of every period. Is that right? Okay, so change it back now, because we can't use begin mode as the default setting. Okay. Right, then something else, maybe just to show that, this is T0, this is T1. If payments are at the beginning, where is the first PMT? At 0 or 1?
0.
Correct. Okay, and see, that makes a difference in terms of time value of money. Here the payment starts there, here the payment starts there. Okay, and that's why the present value of this annuity would actually be 1 period before. Okay. What is a perpetuity? A perpetuity is a never-ending payment. Okay, easiest way to remember, just think about the word perpetual. Perpetual means never-ending. Right, so payments made indefinitely. So do these payments end? No, you'll have payments forever, long after the last one. Okay, it'll never ever end. Okay, this will go to infinity. Right, that's a perpetuity. Right, so here's a few examples that I want you to consider in terms of drawing a timeline. What would the timeline look like for each of these? Okay, is this an annuity due? Is this an ordinary annuity, or is this a perpetuity?
Number 1 is ordinary annuity.
Correct. Why?
Because it's at the end of each month.
Correct. So if we had to draw this, you would have T0 here. You would have T1 here. What would the end be? T what?
T36.
Correct. Okay, because each payment is done monthly, 100%. Great. There's the first diagram. What is this one?
Annuity due.
Good. Okay, and the key word?
In advance.
Yes, paid in advance. Okay, so if you're paying the rent in advance, you're paying that at the beginning of the month, not the end. Okay, so if I had to draw the timeline, okay, T0 to T what?
24.
Correct. Okay, because again, this is monthly. right? And you would show the first payment at time 0. Okay, that's important to note. And always remember to identify beginning or end. The default setting on the calculator is end. You need to look for the beginning. That's the key. Okay. Is that all right?
Yeah.
Great. Okay, so on the next slide, I've given you 2 ways of doing it. Are we going to need the fancy formulas? No. Okay, there's no need to do it manually when you can do it on the calculator. Okay, this is given in the formula sheet. Okay, so when we do past papers and questions, we'll be using a lot of the formulas in the formula sheets. Why? It's good practice for the exam because you'll have it in the exam. You just need to know which equations do I use when. Okay, alright, so am I going to do it that way? No, I'm going to do it this way. Right, the question was asking for what? The present value. Right? I need to identify variables from the question. So if I read the question, we have an annuity which pays per year. That's the PMT. For 3 years, that's the N. Okay? If it's per year, is the N in years? Yes. So 3 years would be fine. The interest is 10% per annum. Is the interest per annum? Yes. Do I need to convert anything? No. Right, so on your calculator, second function clear before you insert. Insert those 3 amounts in and solve for your PV. And what do you get? Correct, that's the correct answer, yes. Right, and it doesn't matter which way you do it. You can use that fancy equation on the left, or you can use the calculator on the right. Either way, you're still going to get the same answer. Okay, your maths is very good. So if you had to substitute into this equation, what would you do? Would you substitute percentages or decimals? Decimals, yeah. So just be careful. If you are using formulas, you need to use decimals. Fractions is even better, yeah. That's also fine. Okay, good. Right, number 2. What is being asked for here? Correct. Okay, again, there's the formula, there's the calculator. Okay, you're not going to have to do it on the formula. You just substitute into the calculator. Right, so again, you read the question, same variables. The only thing different is I'm solving for what? Future value. So you press a different button on the calculator. What do you get? 17,362. Correct. There you go. Correct answer. Right. See how simple it is. Okay, it's just the calculator basically. It's identifying the correct variables and substituting into the calculator. Is that right? Great. Okay, so let's have a look at this one. A few for you to try. Okay. See if you can identify the correct variables, get the values, substitute into the calculator, solve for the correct unknown, and that gives you the right answer.
First one, 184, 794, 85.
100%. Well done. Good. Right, that's number 3. Try number 4. Well done. Shit, this is easy, hey? 38,798.36376. Yeah, good. Nice. Okay, and there's one more after this. Try that one.
Six, 664, 5, 4, and 6.
Well done. Good. Okay, great. Full marks. Good. Okay, those are the 5. All right, so after having covered those, something else to consider is this.
In the exam, will I put those in 2 decimal points?
Yes, in most cases, yeah, you would choose. So the assignment that you had to do for today, some of the questions, not all of it, but that's the type of questions you'll see in the exam. Okay, multiple choice. It's all multiple choice. No need to do workings. Yeah, and that's why if you can use the calculator, use it. Okay, there's no need to play around with formulas. It also wastes time as well. Okay. All right. So what am I going to do when looking at annuities? The shortcut is that, using the calculator. Right. The mathematical equations are only necessary for theory questions. Right. I think there was one in your assignment, which we'll look at just now. Okay, theory questions require formulas. But when I say theory, sometimes they give you that, okay, in terms of the question, and they ask you to make n the subject of the equation. So what would n be equal to? Okay, that's what I mean by theory question. Right, or sometimes they'll say make I the subject of the equation. Right, or make R the subject of the equation.
So you're actually not working out a figure, you just
No.
put in on the one side of the equals.
Exactly. Correct, yeah. Right, that's something that you could see. Right, all you need to do from a calculation point of view is this: if you've been given a, let's say, a numerical question. Okay, so solving for PV, solving for N, solving for I, whatever the case is. Right, if it's given to you as numbers, you would have to insert it as variables. Okay. All right, so here's another. What's different with this question compared to the ones that we've looked at? There's the keyword. Correct. Okay, and what else? Per month. Right, so what must I do with every question that I do? I need to check. I need to check that the variables are the same. Okay, so the 500 Rand per month represents what? The payment. There's it there.
That's just straight 500 PMT.
Yes. Okay. This is representing how many years?
10 years.
Which is?
How many quarters?
No.
120 months.
Yes.
5 years.
Okay. Months with months.
So we go 12
times 10 equals, and then press N. Yes.
right?
Okay. Then what is your I? Your I here is given as 12% compounded monthly. Remember, that's nominal.
We have 12 divided by 12 equals I.
Yes. And then solve for what? Second function clear?
Yeah.
Try again.
So 500 is 20. 10 times 12 equals N. Then 12 divided by 12 is I. And what is 150? 115,019.
Correct. Good. Right, so the key here is identify the variables. Make sure all the variables are the same. If all the variables are the same, brilliant, no problems. Okay. All right, so I've done that one with you. Let's see if you can do this one. Number 2.
Accumulated amount was 18.
Yes.
53,714.
Correct. Good. Okay, that's a tricky one. Okay, you had the right variables. Payments per quarter, number of quarters, I4, interest rate for the quarters. Right, great. Okay, so that's the right answer. The next one, there's one more for you to try. Number 3.
128,453.
No, not quite. Okay, so if I read the question was asking for the present value. Okay, this was semi-annual. So if it's semi-annual, how many payments a year? 2.
Yes.
Okay, so 20,000 is paid semi-annually.
So it was supposed to be 20 was supposed to be my end.
20 is supposed to be your end.
Yes, okay, that's where I went wrong.
All right. Okay, because 10 years are how many half years?
Yes. Okay, so let me put that in again.
Yeah.
Alright, so 18 divided by 2. 20,000 is
That's right one, yeah. Good. Okay. Right, so just be careful. Make sure all the variables are the same. That's the biggest lesson to take away from those 3 examples. Okay. All right, what happens if I give you something like this? Okay, remember earlier on I gave that diagram where we had a possibility for an annuity. Do you agree? Okay, so here we're looking at something a little bit different in terms of a car. Okay, so paying a deposit for a vehicle and you've got a certain amount of installments. Okay, and then we'll also look at a consideration where what happens if I start the annuity later? Okay, what actually happens? Okay, so if John buys a vehicle and this is the arrangement, okay, 10,000 deposit, okay, 36 months to pay, 4,000 per month and a rate of 12%. Okay, do you agree I've got enough variables to work out what? The loan. Okay, because I know how many payments he's going to make. There's the payments he's going to make.
10,000 deposit, I don't use that until then.
You don't use the deposit because the loan is separate from the deposit.
Yes, so the deposit's there to confuse you.
The deposit is there for the price of the vehicle. Okay, because the question asked, how much does the car cost? Okay, so the car costs what? Well, the car costs the loan plus the deposit, exactly. Okay, and that's why I've shown that working there. Okay, so you first need to work out the loan, then you need to work out the cost. Okay, because the cost would have included the deposit. Right, how much interest did he pay over the period? Well, do you agree? If I'm working out interest, how do I work out interest? Do you remember the basic equation? No, future value, that's simple interest. Future value is present value plus INT. So future value minus present value gives you interest. Okay, so how much do I end up paying? I end up paying that amount. What is the actual loan amount? There's the loan amount. So the one minus the other will give me the interest. Okay. Right, so that's just application. I'm just trying to show you other types of questions that they could give you, because they always give you like a scenario, a word sum almost. Okay. Right, we spoke about this earlier. Just remember, a deferred annuity can be either an ordinary or an annuity due. Okay, it could be either or. Which do I have here? Ordinary annuity, end of each period. Okay, so we need to draw a timeline before we can work this out. Okay, so what amount would you need to invest now? Where is now? Time, 0. Okay, so I need to know how much do I invest today, okay, in order to provide for a future annuity in 10 years' time. Okay, so this is going to continue going up until time 10. Okay, what happens at time 10? That pays out a yearly amount of 100,000 at the end of each year. Okay, so T11 would be the first 100,000. Okay, then T12 all the way through to T20. Okay, 10 years time. Okay, so the annuity will run for 10 years. Okay, so 100,000, 100,000, 100,000 all the way up until T20. Okay. For a period of 5 years. Okay, that was incorrect. Okay, I think you might have given the right answer then. Okay, 16. No, 5 years.
Sorry.
5 years will be 15, yeah, each year. Okay, so 11 will be 1, 12, 13, 14, 15. Okay, so if I look at this, do you agree this isn't an annuity, but this is an annuity? Do you agree? Okay, so there's two parts to this question. I first need to look at the annuity. Okay, so what can I work out? I can work out the present value of the annuity. Where would the present value of the annuity be? The present value of the annuity would be at time 10. And once I've got that, I can then discount that back to time
Because that
0.
time 10, the present value of the annuity will be the future value
Of the
T0 to T10.
correct, yes, exactly. Right, is that okay? Are we alright with the diagram?
Well, let's work it out.
Okay, I think I have given you the workings for it on the next page. No, I haven't. Okay, so we do need to work it out. Right, I've got the answers separate though. Okay, do you want to take the diagram down, or are you happy with the diagram?
No, I'm happy with the diagram.
Okay, so let's work out the answer. Right, so first give me the present value of the annuity. Work that out quickly. What is the present value of the annuity?
The present value of the annuity.
Correct.
379.
078. Good. There you go. Okay, you've already got one answer. Okay, so now you have that future value for the current amount of capital you need to save up. Yeah.
Right, so then I'll just go shift here. And then I'll go 379. And that is the future value.
Correct.
And then do I keep the same rate?
Yes, that doesn't change. The rate doesn't change.
10 is I, and 10 is also M. Correct?
Yeah.
And I'll go present value. Yeah, 146, 151.
Okay, good. Right. We spoke about a perpetuity earlier. We now need to know how to do the calculation. Okay, so remember the key word for perpetuity is never ending, perpetual. Right, so if you look at the formula, this formula is given in your formula sheet. So there's no need to remember it. Okay, it's one of the equations on the formula sheet in your exam. Okay, P equals R over I. Okay, or R. Okay, what does that represent? It represents the present value. It represents the payment. R is the payment. I is the rate. Okay, so what happens if I give you something like this? How much must be donated to a scholarship fund that will provide for 10,000 per year indefinitely? There's the key word. How do I know if it's a perpetuity? You will always see something about never ending, indefinite, something like that. Okay, so what do? I take the payment.
Okay, the payment is, we want payment. Yes.
No, you've got the payment.
And how much must be donated to a scholarship fund?
Correct. So that's the PV.
Okay.
That's the capital that must be donated.
So 10,000 is PMT. Alright, interest is 15%, it's compounded yearly. So it's 15 is I over Y. What do I put in?
You don't put any in because it's indefinite.
Okay, so then I just click PV.
No, you need to use the formula. Okay.
That formula.
Yeah.
Okay, hang on.
Right.
Can you practice?
Yes. Okay, so perpetuity means payments over rates. Alright, so this one is literally payment divided by interest. That's it. Simple as that. No time value of money, no present valuing and all of that.
$66,666.
Correct. Okay. Is that right? Okay. Right. And then the last bit in terms of the annuity is this. General and increasing. Okay. So general annuities is what we've looked at so far. Okay, just remember to always check the variables. Make sure the variables are the same. If the variables are the same, I can then use the calculator to work it out. Okay, if you are given rates that are different, you might need to convert. And if I convert, I need to use the equivalent rates formula. Okay, if I'm looking at an increasing annuity, what does that mean? It means the annuity payments are going to increase. So I'll have 500 here. That's going to increase next month by 500 plus Q, plus a portion. And then the next payment will be the payment plus Q. And the next will be the payment plus Q. So it's growing. Every period the annuity grows by a fixed amount, by a specific amount. Right, so there's the definition. An increasing annuity, right, is when the payment increases every period by an amount of Q. Right, every period the payment increases by Q. Is that all right? Okay, so this is the formula that you need to use. And again, it's on the formula sheet. So you don't need to remember it. You just need to know how to calculate it on the calculator. Okay, this part of the question, okay, can be done on the calculator because this looks the same as that. Okay. All right, so there's the notation. Right, the notation here is the payment, okay, S. What is S? S is, in the alphabet, where does S appear? Toward the end. A starts at the beginning. Right, so A goes with present value, S goes with future value. All right, so that's how you differentiate between which is which. Okay, so if I look at this, what am I using? Am I using the future value or the present value? Future value. S is for the future value. I'm looking for the, I could be looking for future value here, yes. Okay, so if I'm looking for future value, I need this, which is the future value of the payments. Right, this bracket here represents the R. Okay, so I can put that into my calculator. Okay, here's an example. What do I put on my calculator? Well, let's read the question. Okay, what does this 1,200 represent? Yes, which represents that. Okay, what does the Q represent? Correct.
So we say 1,200 plus 200
Divide by?
divided by the interest rate, which is 15.
Gives you what? What does that give you? 2533,333. Okay, so now you've got that bracket. Okay, that bracket represents, inverted commas, a payment. Right, now I can take that 2533 and I can plug it into the financial calculator because I make the 2533 my PMT. Okay, and I put in the N. What is the N here? The N is 20, and what is the I? 15. Okay, so on your calculator, on your financial calculator, you've got the payment now. Put in the I of 15%, put in the N of 20, and solve for the FV. That's how I got that. There you go. Okay, so that's how we do it. We first need to work out the bracket.
How did you get the 74? Because I got 259.
Okay, you need to put in more threes. More, because it's a recurring decimal. So just type in as many threes. Just type in 3333333 and then press the payment. Okay, yeah, so just be careful if there's a recurring decimal. Just put in maybe 6 or 7 of them. Put in as many as you want to get the right answer here. Okay, so now you know how to work out this bit. So what I did with you there was the bracket. Okay, was this part. Okay, that gives me that. And then I just subtract this, which I do on my calculator, normal scientific. Right, you get that answer, you subtract the one from the other, and there's the final answer. That's how much you would get.
What's the 26? 366
The 2666 is this.
in Q. Okay, so.
Okay,
So
the N is 20, the Q is 200, and the I is 15%.
Okay, so 20 times 200.
Okay, so it's a two-part calculation. It's one equation, but two steps to get to the answer. Does that make sense? Great. Okay, and that's it. That's all the theory that we need to look at. Now we can look at the, I think there's 15 questions, and then that's it for today. Okay, do you need a quick stretch? All right, great. So let's start with question 1 then. All right. Question 1 is focusing on what? Simple interest or compound interest? Correct. If you see simple interest, I need a formula. Do you agree? Okay, and the formulas will be in your notes, so we can use that, or you can just remember it offhand. Okay, so I just want to put assignment 1 here, so I can send this to you. DSC 1630, semester 2, 2016. Okay. All right. So question 1, you tell me, what do we have in the question? What do we have in the question?
Okay, you've got the future value.
Yes.
15,000.
Yes.
Right. You've got your interest.
Yeah.
And you have your time.
Yeah, so what am I working out?
You're working out your present value.
Correct. Okay, so 15,000 equals PV, brackets 1 plus RT. The ratio was 0.125. Okay.
Time was 9 over.
Time was, no, not 9 over 12. Okay, what do we have here? Do we have 1 loan or 2 loans?
No, we have one loan. She has to pay Ishmael 15,000 2 years from now. Right? She decides to pay back earlier.
Yes.
Right?
Okay, so
Okay, if the simple interest rate of 12.5% per year is applicable, then the amount that Susan will have to pay Ishmael 9 months from now.
okay, so do you agree it's a picture you need to draw? Okay, we can't use 9 months. Why can't we use 9 months?
Because we don't have a present value.
Exactly. Okay, where are you starting? Exactly. So if I'm starting at the end, how many months am I actually discounting it for? Yes, that's correct. Okay, 24 back to time 9. Okay, 15. Sorry, the cable has come out. Okay, 15,000. 15,000 is the future value. How much am I discounting it for? 15 months. Okay, this is how I get the present value. Okay, so it's 15 over 12. Right, that's what you need to do. Okay, because it was simple interest. Simple interest was what? Future value equals present value. 1 plus RT. Okay, so I'm just substituting and I'm solving for present value. Okay, the tricky bit.
That's the interest formula, yes?
That's the simple interest formula.
Not discounting.
Not discounting. They didn't say simple discount. They said simple interest.
Okay.
Simple interest. Simple interest. Simple interest, you use the R. Simple discount, you use the D. Remember that? Yes?
Okay, yeah, I got you.
Okay.
Right. So for the simple interest, surely we have to.
You type that into a calculator.
Surely this is a 2-bit question, and we have to find out what the original amount of the loan is.
No, you don't. Because they're asking you to take the 15,000 Rand that's at time 24 back to time 9. Yes.
So do I do it on this calculator?
No. Simple interest is a formula. Okay, so you do it like I'm doing it there. Okay, solve for PV, right? And you get option 2. Option 2. Is that right? Great. Okay. Right. Question 2. What stands out here? Well, here they talk about simple interest and they talk about simple discount. When you see both, when you see both in the same question, just remember what we spoke about last week. Interest is R, discount is D. So do we have both in the same question? Yes. So what do I use? There. The additional useful past paper formula, there's it. Okay, so I use that for working out this. D over 1 minus dt. Okay, so if I go back to the question and I read it again, I get 0.24 equals 0.205 divided by open brackets 1 minus 0.205 t. Close brackets. Okay, solve for t. Right, if I solve for t, t comes out to 259,65 days. Okay, that's what you get if you're solving for t. Okay, well, you actually get time. Let me just show you this rather. Time comes out as, there's 2 steps here. Time comes out to 0.71138211138 years, okay, which you would then multiply by 365, okay, to get days, yes, because the question asked for days. All right, so yeah, it's easy to get the t. You just need to remember to times by 365. Okay. Right. Question 3 is the nice question. Did you get an answer for 3? Okay. Yeah, that's an easy question. Why do I say it's easy? Exactly. It's this, effective interest. Right. So you're going to have to work out what? EFF. Okay, that's what we're working out. Solve for EFF on the financial calculator. Okay, so you're putting in, okay, I'll type it in and you can just look up when you're done and check your answer. Okay, you need to change your P over Y. If it's every second month, yes. Good. 16.5 as the I. Yes. I. You need to put it in as I. Yes. Okay. Just write down the steps, so you remember how to do it. Okay. Take some time to get used to the calculator, so just make a few notes for yourself so you know what steps to do on the calculator. Okay. Right. Question 4. What's the focus here? There's always a keyword that stands out. No. Keyword is this. Yes, discount rate, because that tells you what formula to use. Okay, that stands out. Okay, that's the big keyword. Okay, because as soon as you read that, you then need to type in the correct formula. So PV equals future value FV brackets 1 plus minus DT. Okay, that's because it's simple discount. That's the only reason why I'm using that formula. Okay, so PV equals 30,000. Open brackets 1 minus the discount rate of 0.165 times 8 over 12 close brackets, solve for PV, and PV comes out to option 1. Okay, yes. Nice, you even had the answer before me. Okay, good. Okay, so simple interest is simple. That's the point I'm trying to make. Don't overcomplicate it. Okay, question 5. What keyword stands out here? Simple interest. Good. Okay, so all you had to do here was work out the simple interest. Okay, Moses needs 10,500 in 10 months' time. Okay, that's from today. Okay, 2 months ago he deposited 9,000. That's the present value, right? In his savings account, a simple interest of that. How much money will Moses still need to buy the lens 10 months from today? Okay, so what did he start with? He started with 9,000. Okay, what do we want? We want the future value. Okay, so the future value equals the present value brackets 1 plus RT. Okay, future value equals 9,000 brackets 1 plus the rate 0,115 times the time, which was 12 over 12, which is 1. Okay, if you solve for that, you get 10035. Okay, what did the question ask for?
How much more money does he need?
Correct. Exactly. Well done. Okay. Right, question 6. What stands out here? Good. That's key. Right, when you see that word discount rate, I need to use this equation. PV equals future value brackets 1 minus dt. Okay, now I need to interpret. Okay, did they give me an element of time here? Good. Okay, but can I use that in the question? No. So what must I do? Not how many months, or I could use months, or I could use days. Right, it's going to be easier to use days. How many days in the year? Correct. Correct. Alright, so if I count the number of days, in the textbook, they've given you a table. You can't work this out on your calculator. If you had a different calculator, I could show you how to do it, but you're going to have to use this, the counting of days. Where is that page? How did you get 63? Is 63 correct? That's very impressive. Well done. Okay, did you do this ahead of time? Did you do this ahead of time? You just worked it out now. Each month. Okay, awesome. So if that's the case, great. Right, how you get it is fine. Okay, but you got the right amount of days. Okay, so if I'm working out the amount here, 63 days, so PV equals, the PV here was 5,000. He received 5,000. Okay, so 5,000 equals S future value, brackets 1 minus 0.18, open bracket 63 over 365. Close brackets, close brackets. Right, solve for future value and you get option 2. Okay. Right, question 7. What stands out here? Good. So this should be easy, right? Yes. Compound interest is always done on a normal financial calculator. Simple, you need formulas. Okay, so I'll write the variables down. You try do it and see if you get the right answer. Well done. Option 2 is correct. Good. Right. Question 8. What stands out? Correct. Okay. Notice this is one of those almost like mathematical type questions. Okay. So I need the formula, but you already know that simple interest always requires a equation. Okay, so 1 plus RT, close brackets. Okay, the simple interest or the simple interest future value was 460 equals 400, brackets 1 plus 0.08 t. Okay, if you solve for t, you should be getting option 1. Okay, so there's the equation, there's the amount. I take the amounts to the left and the right. Okay, I do some mathematics, and option 1 is the answer that I'm left with. Okay, question 9. What stands out here? Good. Okay.
Is this where I use the
Conversion, equivalent rates. Okay, so this is a conversion question.
1 plus I
M to the M.
to the M equals 1 plus I M to the M.
Correct.
Okay, and the M is
Okay, the M is always what you want. Okay, so this is what I've got.
so the N is
What do I want?
N is 52.
I want 52.
Oh, so the M is 52.
M is 52.
N is the
N is what I have.
okay.
Okay, so what do I have? I have the nominal rate. No, I have the effective rate. So I have I1. I have I1.
Okay.
Alright, so that's what you have and that's what you want.
So 1 plus I 52 to 52 equals 1 plus 26.6 or 29.61. 1 to 1. Okay.
Do we get that? But then did you times your answer by 100? You probably got an exponential function or scientific notation.
No, I did it the wrong one.
Oh, okay.
Instead of
I need to get rid of the exponent.
No, because what I did is because it's to the power of 1.
Yeah.
So I just removed that because anything to the power of 1 is itself.
Oh no, you can't just remove it
Yeah,
because you
and
need
then
to
I brought-
take.
No, and then I brought the 52 across to the 52nd root.
Okay, no, that's wrong. Okay,
Okay. So
right.
So I'll say
There's it. Brackets 1 plus 0.2961, close bracket to the power 1 over 52, minus 1 gives you a scientific notation amount, then just times it by 100 to get a percent. Still not getting it.
no. I think I just went over.
Type something in wrong here.
Okay. So
Brackets 1 plus 0.2961, close bracket. Put the power button.
1 plus 0.2961 close bracket.
Put the power. Open a bracket. 1 divide by 52. Close that bracket. Close that bracket. That's for the exponent.
Okay. Oh, and then I minus 1.
And then minus 1 equals. Now times that answer by 100 to get a percent. And it should look like that.
Yes.
Okay, there we go. There we go. Right, that's the percent.
That's not the answer.
That's not the answer because what is this? This is effective. What did the question ask for? Nominal.
So I just times that by 52.
Yes. Times it by 52 and that gives you option 1. Okay, remember nominal and effective go together, yeah. Alright, we're almost there, last 5. Okay, question 10, easy question. Okay, all you had to do was identify the key variables. Alright, so I'm working out the accumulated amount. So PV here was 107,250. I is the I that you have, I3, because it's every 4 months. Every 4 months is 3 times a year.
7250 is my PV. And then
N is 5 times 3, which is 15. And solve for
what's the interest rate?
FV.
Okay. 8125 is my interest. So,
Divided by 3, because it's every 4 months.
yes. 16110.
Correct, option 2. Nice. Okay. 11, keyword that should have stood out here, simple interest. So 45200 equals the present value, brackets the 1 plus 0.12t, right? And then you solve for t, which comes out to option 4. Okay, it wasn't a difficult question, you just needed the formula again. Okay. Right, question 12 was an easy question. Okay, you might even want to try do this one on the calculator, straight into the calculator, see if you get the right variables, and then we'll check. I'll put the answer, I'll put the workings here for you. Just remember, PV and FV, one must be negative, otherwise the calculator gets confused.
One must be negative.
Yeah,
Either one.
either one, it makes the difference for this. You press the plus minus button on the left in the middle. There's a bracket minus. Okay. Do you type in the figure first, then you press the button? Okay. Type in the figure first, then press the button.
Is 30 over 12 my N or is 30?
30 over 6 is your N. Why? Because it's semi-annual. So how long is a semi-annual period? 6 months.
So 5 is my N.
5 is your N, correct.
I'll just say I over R.
Yes. No. Yeah. You just press I over Y. That's what you're solving for.
6.97.
Correct. Then you times it by 2 to get the nominal rate, because the question asked for nominal. Correct. Option 3. Good. Okay. Not so bad, eh? Take some practice.
No, it just takes practice.
Okay. 13, keyword that stands out here, simple interest. Okay, there was a lot here in simple interest. So 4,500 equals 4317,26, open brackets 1 plus RT, which was 0,15t. Okay, solve for t and you should get 0,218,515 years. Times it by 365 gives you 102,9975 ... days. Okay, and then count to 103 days from 5 May, right, to get to option 2, okay, which is 16 August. Okay, so you get the answer, then you just need to move it forward. Okay, question 14. 14 was the most difficult question in this particular assignment. Alright, so this particular question needs a timeline. NB, this is a tough one. Okay, you needed to draw a timeline. Okay, timeline is key. Okay, so if I read the question, okay, and you plot everything in the timeline, you'll get T0, you'll get T10, you'll get T28, and you'll get T32. Okay, this is the timeline that you would have drawn from the information in the question. Yeah, it's up here. Okay, 0, 10, 28, and 32. Okay, there was a loan here of 3,000, and there was a loan here of 25,000. All right, so I'm trying to build a timeline. Once I've got a timeline, then I can move things backwards and forwards. Okay, so the question was, what is the amount that Cat will pay 28 Jan? Okay. Sorry, yeah, I'm thinking, okay, Jan's the name. Okay, we'll pay Jan 28 months from now. Okay, all right, so I'm looking at this. Okay, that's what they're looking at. Okay, so we're wanting this amount. That's the question mark. Okay, so do you agree? What do I need to do? I need to move things backwards and forwards. I need to take that X that side. I need to take this there. And I need to take this there. Right. But my loans must equal my payments. That's key. Okay, so my loans is a 3,000 Rand loan. Am I taking it back or forward? I'm taking it forward. So 1 plus the rate. The rate here was given as 0,1475. Okay. And I'm taking it forward. This was simple interest. So I have to take it forward how many months? 10 to 28 is 18. 18 over 12. Okay, so now I've taken this loan to that point in time. Okay, then I still need to add the other loan. That loan needs to be taken back. Okay, so 1 plus, what is it, RT? This was 1 plus, hold on a sec, it'll be taken back, so it'll be divide. Divide by brackets 1 plus, the rate was 0,1475, okay, times 4 over 12, close brackets. Okay, so that's the loans. I'm just going to write that down. There's the loans. Okay, so that's the loan part of the question. Then you need to make that equal to the payments. So this is the loan. Okay, those are the loans. Okay, taken back in time. There are the loans. Okay, so I'm taking the one loan back and I'm taking the 1x forward. Okay, so that equals x plus x brackets the 1 plus, okay, taken forward. How many periods did I take it forward? 28. Okay, so there you go. Right, so now I've got those x's. Okay, those x's are taken forward, okay, and the 1x is at that point in time. Those are the payments. Does that make sense? Okay, so I'm taking the 1 forward and the 1 back to get the final answer. Right, if you do some arithmetic, okay, your x, well, you'll get this. You'll get 366, 3,75 plus 23,828, 43527 equals 2,344,166,667x. Okay, and then you solve for x, and x comes out as option 3. Okay, so this was the loan part of things, and this was the payment part of things. Okay, so the one equals the other. I'm taking those there, I'm taking that there, and I'm taking this there. Right, your payments and your loans must equal, because that option 3, yes. Okay. Right, and then the last one was an easy question. You had to just identify variables. Okay, this one you might even be able to do it now quickly on your financial calculator. Okay, let's quickly type that in, see what you get. I'll type the variables here and then you can check. 8388. Okay, let me just check. Okay, after 52 months, compounded every second month. So it'll be 52 divided by 2 gives you 26 periods.
52 divided by 6.
Divided by 2.
Every second month.
6
times in the year.
Every second month
Divided by 2
gives you a number of periods. Okay, each period is 2 months long. Okay. I here was 9.7. Compounded every second month. That's I6. Okay. Alright, and then present value was 7,300, and we're asked for the future value, option 4. Okay, solve for FE, option 4. Alright. Okay, Anthony, happy?
Yeah.
Great.